Okay, so here is the system of inequalities. If X is the hours spent babysitting and Y is the hours spent landscaping, he can spend at most 20 hours a week working on those. So X plus Y, the number of hours babysitting plus the number of hours landscaping, has to be less than or equal to 20. At the same time, if he makes $3 an hour babysitting, so 3 times the number of hours babysitting plus 7 times the number of hours landscaping, he's got to earn at least $84 a week. So that total amount of money has to be greater than or equal to 84. And of course, we can't have negative numbers of hours, so the number of hours babysitting has to be greater than or equal to 0, and same with the hours spent landscaping. So it wants to know what's the most number of hours he can spend babysitting if he wants to meet these constraints. So what I'm going to do is graph these inequalities, and I'm going to answer the question by examining the graph. So I need to graph these two lines, this line and this line, if these are equal signs. This one we've done a million times. It's just got an x-intercept of 20 and a y-intercept of 20. So 20 here, 20 here. I'm counting by 2's on each axis. And I graph that line there. That's the boundary line. And 0, 0 works in the inequality, so we're shading below that line. The other one, I'm just going to use the find the x and y intercept of this equation. So if you set, for the y-intercept, if you set x equal to 0, you get 7y equals 84. Divide both sides by 7, you get the y is 12. So there's the y-intercept. The x-intercept here is, you let y equals 0, 3x equals 84. Divide both sides by 3, you get that the x is 28. So I have the x-intercept of 28. So there's that line. Now let's check to see if 0, 0 works in this line. If you put 0, 0 in here, you get 0 is greater than or equal to 84. Not true. So we're not shading below this line, we're shading above. And of course we're working in the first quadrant because it's both are positive, but we'll just assume that. So it's above this line, right? And below this line, so that's this little triangular region here. We're not trying to find the area of anything like we've done in the past. We're trying to think about this. So what's the most number of hours babysitting along this axis that she can do and meet the requirements? Well, that's this point right here, which we don't know that it's 14.6 yet. We haven't done the work, but it's this point right here. So like this is the maximum number of hours babysitting. So to find that point, we need the intersection of these two lines. So I won't go through all the details, but I set these two equations up. X plus y equals 20, 3x plus 7y is equal to 84. I'm going to solve these using elimination. Quickly, I multiply this equation by negative 3. When I add them together, I get 4y equals 24, divide both sides by 4, I get the y value is 6, plug that into one of the originals and get the x value is 14, which means that this point here is 14 comma 6, and the maximum number of hours he can spend babysitting is 14 with 6 hours of landscaping. That will earn him the $84.